Lesson 10-1, Sequences as Functions. Objective, relate arithmetic sequences to linear functions, relate geometric sequences to exponential functions. A sequence is a set of numbers in a particular order or a pattern, and each number in the sequence is called a term. A sequence may be finite, so it has a set number of terms here, or infinite, so it has this pattern, but it goes ... means it continues. The first term of the sequence is denoted a sub 1, the second term is a sub 2, and so on. So the domain will be the position, first term, second term, third term, and the range will be the actual number that aligns with that position. And this is an example of finite, this is an example of infinite. And again, you can see the domain and range, domain and range. In this example, this is called an arithmetic sequence because there is a common difference. In other words, there is a constant value that will take you to the next value here. So to go from 3 to 6, you would have to add 3. To go from 6 to 9, you would add 3. So you're adding 3 to the previous term. Let's take a look and decide whether this sequence is arithmetic. So what I want to do is I want to find out what it takes to go from -3 to -8, and I would have to be subtracting a 5, or you can say adding a -5. And to go from -8 to -5, I would be subtracting a 5. And going from here to here, I would be subtracting a 10. Now, in order for it to be arithmetic, it would have to be subtracting the same number. So the answer is no. The sequence is not arithmetic. Let's take a look at another example. And again, we're going to take a look at what the common difference is. It looks like to go from the small number to this large number, we're going to add 6. From a small number to this large number, we're going to add 6. Small to large, we're going to add 6. So the answer is yes, it's arithmetic because it has a common difference. Your turn. And here's the answer. Your turn. And here's the answer. Let's go ahead and take a look at consider this arithmetic sequence at -8, -4, -2, -8, -4, -2, and it looks like I am adding 2 each time. And it asks me to find the next 4 terms, so I'm going to continue to add 2 and get these 4 terms. Now I'm going to graph this, I'm going to graph this as an x, and this is my y, my x and my y, x and y, and I'm going to graph all of these points, and you can see it looks linear. So an arithmetic sequence is a set of numbers, and when you plot them with their position number and the number, it'll look like a line. Pause, and here's the answer. Pause, and here's the answer. Let's take a look at another kind of sequence, and it's called a geometric sequence. Each term is determined by multiplying a non-zero constant by the previous term. This constant value that you're multiplying is called a common ratio. Let's look at this sequence, 1/16, 1/4, 1, 4, 16. And it looks like we're multiplying by 4. To go from 4 to 16, we're multiplying by 4. From 1 to 4, you're multiplying by 4. 1/4 to 1, multiplying by 4. 1/16 to 1/4, multiplying by 4. Let's now determine whether the sequence is geometric. Now this is not so easy, so what we're going to do is I'm going to compare the 20 to the 8, and when I reduce that, that is going to be 4 goes into there 5 times, 4 goes into there 2 times. So we're actually multiplying by 5 halves. So let's take a look at, are we multiplying by halves to get the 50? So if you take 20 and multiply by 5 halves, the answer is 50. So to go from here to here, you are multiplying by 5 halves. Now the question is, are you taking 50 and timesing it by 5 halves again? So this is going to be 25, and then that'll be 125. So going from here to here, you're multiplying by 5 halves. So the answer is yes. We are multiplying a common ratio to get to the next term. Let's take a look at this one. The ratio would be 30 divided by 19. This is a prime number, so we can't do anything. Now to compare the ratio from here to here, that's 41 out of 30. Now this ratio is not the same as this ratio, so the answer is no. It is not geometric because I'm not seeing a common ratio. All right, you decide. And here's the answer. Your turn. And here's the answer. Let's take a look at graphing a geometric sequence. So over here, we have the first three terms, and what I want to do is I want to figure out what the common ratio is. So this is 15 over 10, which ends up being 3 halves, because 5 goes into there 3 times, 5 goes into there. Now the question is, when I take 15 and times it by 3 halves, do I get 22.5? And I'm going to use my calculator for that. So I'm just taking 15 and timesing it by 1.5, and I do get that. So I'm going to times by 3 halves, or 1.5, and I'm going to do that each time. So I'm going to take that and times it by 3 halves. I'm going to get 33.75 times by 3 halves. I'm going to get 50.625 times by 3 halves, and I'm going to get 75.9375. And that's how I find them. Okay, so now here are the numbers that I just wrote down, and here is the graph. Now notice that the graph does not look like a line like the arithmetic. In fact, it has this exponential look. Okay, pause and see if you can figure out the next 3 terms. And here are the answers. Pause to see if you can find the graph. And here's the answer. All right, let's take a look at a sequence and determine whether it's arithmetic, geometric, or neither. So the first thing I'm going to do is I'm going to try to figure out what it takes to go from here to here. And it's going to take adding a 12. And to go from here to here, it's going to take adding a 12. And here, from here to here, it looks like it's adding 12. When I'm adding a common difference, the answer is arithmetic. And my reasoning is because it has a common difference of 12. All right, let's take a look at this one. Now, when I add, it's 3, but when I add over here, it's going to be 4 and then 5. So I already ruled out arithmetic. So the next step is to try to see if I have a common ratio. 5 divided by 2 for these two, and for these two it's 9 divided by 5, and already I see the ratio is not the same, so the answer is neither, and that's because neither had a common difference or a common ratio. Let's take a look at this one. Now this one is going back and forth from going from negative to positive, and a common difference would not do that. So I'm not even going to try the arithmetic. It won't work. So I'm going to try the common ratio, negative 12 divided by 6. That's a negative 2. And if I multiply by negative 2 here, I'm going to get that. If I multiply by negative 2, I'm going to get that. So this is going to be geometric. Explain my reasoning. It's because I have a common ratio of negative 2. Okay, your turn. Here's the answer. Your turn. Here's the answer. Your turn. Here's the answer.